continue.
Just bear with me, John. It's just
Dennis here.
Oh, sorry, Dennis.
Right.
Is this my presentation here that I can I move through here to present?
Yes, you've got to share it first of all, and then you can just, after I've done the intro, you can just launch it.
Okay, just bear with me. Mine's coming up. Oh, jeez, this is unbelievable. Yeah. I prepared so much for this.
Technology, eh?
Yeah, okay, I'm ready.
Okay, good to go. Right. Well, good afternoon. Well, let me just check if everybody's. Let me just check first of all that. Right. Good afternoon, everybody. I hope you can hear me. My name's Dennis Goodlad, and I'm the moderator for this breakout session this afternoon. I'm very pleased to be able to welcome Paul Hingley, who's the business unit manager for, let me get this right, Industrial Security Services at Siemens. So welcome, Paul, and I'd like to hand over to you now.
Hi there, good afternoon, everyone. As Dennis knows, I've come to this presentation by having faults within Teams, so I've been struggling to get on board, but it's a pleasure to be able to present to everyone today. And if you have any questions at the end, please just forward them, right, and we can answer.
I've not got your presentation on my screen at the moment. Did you launch it?
I have launched it.
Yeah. Let's see what's happening on there.
Can you see it now, Dennis?
Just yes, yeah, we're away. Good.
Okay.
Thank you.
I'll just wait for it to come up here because it's still struggling.
I have launched it. Yeah. I'm talking to myself now. All right. Yeah, I think you probably need to put it. Yeah, it needs to be in presenter view, and then go for it.
Just wait for it to come up here because it's still struggling. I have launched it. Yeah.
I'm talking to myself now. Okay, are you
back there?
I think you yeah, that looks fine.
Go okay. As I was saying before, there has been some issues with Teams, so welcome to this afternoon's presentation, and thank you to the Water Recruitment Show for asking us to present. My name is Paul Hingley from Siemens. As Dennis introduced me there, I look after a business unit which is for industrial security and safety services that we promote into working with our customers. And I'm also the PSSO for Siemens in GB and Ireland, which is Product Solution and Security Officer. So the presentation is looking at really the threat landscape that we have to deal with from an industrial perspective, and then also looking at the threat landscape itself, how that's influencing the digital transformation that a lot of our customers are involved with, and I'm sure a lot of people that are listening to this today. And then looking at how we work with our customers around one particular standard, the 62443 standard, and how that is introduced into the project and the solutions that we ultimately deliver. If we look at the ICS attacks, one, they are becoming more noticeable. They're hitting the press headlines quite significantly, and a lot of them now are specifically targeted and being targeted from the criminal fraternity. Industry is seen as a low-hanging fruit, and especially the SME market. So it's not just a case where large companies are being hit with security attacks. They're also looking at attacking the SME type community as well. There are other attacks that take place, especially in critical national infrastructure, which are in some cases state-driven as well. And the way that approach, the way the attack is influenced, and the way that then it is implemented is slightly different. but it still has the same consequences, and that is potentially severe commercial losses, along with reputational losses, and along with potential losses in life if we're looking at denial of service. So in the current climate, there's a lot of reports out there as to what is happening and where this threat landscape is taking us. If we look at the most recent one that was in the water industry, and it highlights the way that industrial control systems are susceptible to a prolonged attack. But a lot of the basics, when you look at it, are not being followed, not by the larger control that's specified within companies, but also the lack of understanding, the lack of maturity of the people that are putting these systems together. And a lot of this is being driven because of the growth in the digitization, the use of IoT or industrial IoT. It is predicted that in excess of 50 million devices will be connected between now and 2025, and that's been had an effect from the pandemic we recently moved through, with the rate of change that was going there. But there is a thirst now for using and utilizing data, and it's at that point that customers have to really understand that transition of data, because alongside the opportunities that digitization brings, the way that data can be used in real-time solutions, we also have to accept that along the risks that we're encountering as well. There are lots of attacks that have been well documented, but if you look at the timelines, these go back, way back into the 1990s. As we moved into a digital age, as we started to see the benefits of interaction with data, so it opened up these particular risks. And while a lot of companies understand that there are these risks, it's usually from a personal perspective and attacks that have happened in our personal life around our own social media accounts, our own technical devices, that sometimes we forget that those same types of technology are used within the digital space. As we look to develop this, as we look to see how we interact, the traditional methodology of building industrial control systems is still the basic requirements of what we do. The engineering concepts, the way that we have that agility in developing control systems, is still at the heart of the way that these are developed. But what we're adding now is the fact that we have the ability to utilize data. And as we use this within the supply chain as well, we have to ensure that the security is built in not only to the products, but the solutions that are developed and put there into providing the processes that we come to expect from the industrial control systems. The threat landscape around this is still a decision process that our customers have to work with. The Internet of Things is there. The sensor technology is increasing. When we look at IoT devices, they are being utilized more and more. But I would argue that, are we going to see an attack directly from a sensor? Generally not. Where we are going to see the boundaries and where we are going to see these attacks is around the edge devices. This is where we are shifting more data, and where you can hide an attack and then exploit an attack into the system and the control system itself. So it's really important to understand the physical connections that we have, the way that we control data from the sensor into the edge devices, and then how we communicate that data into other elements of the control system. Platform to platform communications, when we look at addressing vertical segments of data transfer as well, are going to be a real consideration of the way that we build these control systems. If we move to the attacker, what we're seeing from there is that some of these guys are classified as ethical attackers. That means they haven't been caught, but these are the guys that are out there. They're trying to promote not only themselves and their competency and what they've done in order to facilitate a vulnerability or identify a vulnerability in a product or a system or a solution, but it's also around these attackers then using the information that they gather to potentially that being used from a criminal activity or from an activity that could potentially inadvertently produce an attack within the process itself. So it's understanding this environment, this new world that's developing. We do really need to understand exactly how we are working with and also working against what we need to do to provide that level of protection in the control system. The vulnerabilities, these are regularly announced. We as Siemens have a product cert, but there are other product certs out there. And again, the community, the engineering community, needs to be more knowledgeable about where these vulnerabilities are posted. Make sure that again that you're up to speed with what's happening out there and with particular products and solutions. That enables you to then start developing that defense in depth approach, ensuring that those vulnerabilities are contained and controlled and monitored. And the final element of this is regulations. We've seen in the Queen's speech that a law will be introduced this year with regards to the way that IoT and the internet and the way that we work with data. This will also have an effect on industry. It means that regulations and legislation will become an integral part in the way that we build this. And I'll come on later to some of the interactions that are taking place between safety and security and why we really need to understand how these two disciplines work together. But our customers now are in this scenario where they are looking at how they understand their plants, their industries, whether it be from a regional perspective or whether it be from a global perspective. They're having to sit down and make key decisions in the way that they move forward, how they utilize and embrace digitization, but at the same time, how do they work with the constraints, the legislation, and also the working with the delivery mechanisms for systems and processes they want to develop within their plants and production lines. So first, one of the big questions is they ask us, what do we actually need to protect? A lot of the times there's no inventory. They don't understand, a lot of companies, what is actually connected on their networks. They don't really have an understanding of what relevance those particular products are to the control side of their systems. What level of security do I need? Again, trying to make a customer or deliver to a customer an understanding of what level of protection they should be looking to design into their control systems can be difficult. And this is where the 62443 standard and the SL requirements allow us to at least have a combination of conversations around what they're trying to achieve. But it's defining the scope and the engineering documents of the output that are really important in those initial stages of conversation with the customer. And then how do I protect specific assets? And this comes down to the technology, how you're developing, how you're creating those architectures for the transfer of data, for the utilization of digitization, and how you bring that together. And these are real discussions around levers that have to be addressed. So the customers themselves looking at their IT infrastructure, looking at how they handle their internal processes, how they look and develop resilience, how they improve their processes, security features, and enhance awareness, the training as well, because there's a lack of maturity within the engineering community around what should be done from a security perspective and how that interacts with traditional engineering skills that we have. Ultimately, what the customer requires is shifting from a risk scenario where there are multiple risks from the technologies and the systems they're utilizing to a secure business proposition where resilience is at the heart of the way that they're building their systems and the way that they're protecting and their processes within their plants. So a secure business is ultimately what they're trying to achieve. And in this process, it includes the safety of their systems as well. They're looking for a more sustainable business approach. They're not looking to have vulnerabilities, create disruptions within their production processes themselves. But around this, they also need to discuss and understand that there is a training process as well. It's not just about bringing together in industry, especially an IT graduate that comes along and very quickly is solving the issues around the industrial control systems. In fact, I would argue a lot of the time it is far better to have an electrical mechanical engineer who understands the processes, being more educated around how security can alter what they're trying to do from a design perspective. So bringing all of these disciplines, the engineering disciplines together, is key to the OT community. And it's key because when you're talking between IT and OT, there are distinct differences. In the world of IT, it's CIA, and I'm sure you've been to many presentations where they look at this, where confidentiality is king, where in fact it's in OT the complete opposite. Availability is king. We have to work with timeframes. We have to ensure that what we're moving that data around, as we move that data around the system and around the plant, we're doing so where we're ensuring that uptime is maintained. We ensure that we are working within milliseconds of updates rather than in seconds or even minutes. In the world of IT, the movement of data, it can be minutes or even hours because it's for information only. We are not affecting the decision-making process within real time on a system, on a production line. Integrity is still there. We have to maintain the integrity of the data that we're moving. So security now around that data, the way it's packaged, is important. And confidentiality is actually becoming more important because of the way that customers are utilizing their staff and how they integrate into the process. So confidentiality, information that is personal to the operative, for example, could be used within security around processes in the future. The next slide really starts to depict how this unfolds. If you look at the differences, two areas I want to draw your attention to is the first one, asset life cycle. If we look at the asset life cycle in the investment cycle, you can see that in IT, 3 to 5 years is where we see hardware, software investment to ensure that the fundamentals of that operation within the IT is maintained. The Windows updates, the PC platforms that you're working on, the server capacity, because the amount of data you're creating. But then look at it from an industrial security perspective. We're looking at plants that are going in and solutions that are 20 to 40 years with regards to their investment cycles. That means we really have to understand how we manage legacy. The same is applied to extending existing systems and the way that we look at that from a legacy perspective. How do we encompass the control elements that are from 20 years ago into the control elements that we have today? The new technologies that are being and advancing the way that we develop these solutions need to be addressed within the decision-making process. And at this point, again, I reiterate, bringing together the IT and the OT engineers is critical into making those decisions. The other one I want to bring your attention to is the bottom one, the availability. As I mentioned previously, we have to work in less than 300 milliseconds. In fact, I would argue that if we're looking at safety relevant information, it's less than 150 milliseconds. And if you're looking at reactive safety with regards to safety critical elements, it's probably, and it is, less than 50 milliseconds. So we're now talking having to make real-time decisions that could affect the overall process itself. And this is where the technology development that you're seeing around edge computing, around analyzing data and affecting decisions in real time, really have to use the basic principles of engineering at the same time looking at exactly what we have to do to protect and secure that data. There are regulations emerging. There are ways that the integration of standards is being developed. And as I mentioned before, we focus in on the 62443 standard because we believe that encompasses all of the elements that are required to look at a validation and verification process of design. Also looking at it from the maturity lifecycle management, i.e. the policies and procedures and processes that are put in place to manage all of the conditions around security. So if I draw an analogy on that, the same principles that are used within safety and have been used for many, many years under the 61508 standard for safety. Those principles, the analogies you can draw on what we're trying to achieve with 62443. The way that we should start by first auditing the system, the way that we should be gathering information to understand the principles of the system and what that system is designed to produce, that scope of supply is critical into the way then that you work with the standards and then define the standards within the overall control. So we're back to really understanding the existing original principles of engineering that then relate into this new world, this new idea around IoT, around security, and the way that data is being used. So the 62443 standard, how do we apply it? It's broken down into various elements. So risk and vulnerability, it's evaluating people, it's evaluating the site. How does the personnel, the various levels of control around these individuals work together? So the maturity level is brought in. The processes then are developed to ensure that the way that the system is being managed and implemented is controlled. It means that we are constantly re-evaluating the design process to ensure that what is being put together as an architectural design for the network and that interaction of shifting the data is also compliant with the standard. The SL levels that are in there are really important because you need to understand at what level you're trying to achieve that ultimately brings all of these processes together. So the technology now becomes a really important issue in the way that you are working with the standard, i.e. is the product that you're utilizing compliant with 62443? If it's not, then why not? Ask the questions and in the supply chain, raise the awareness as well that you are trying to achieve a particular SL level of the standard, and also what that is as relevant to the overall system and process. And within that, it is defined. If we look at the asset owner, if we look at the system integrator and the product supplier, the standard itself is designed around those three key elements. The asset owner is responsible ultimately for the product, the solution. They operate and maintain the system. So for them, it's ensuring that all the elements, both technical and also from maturity, process control, are brought together. The system integrator, they're the one that is involved in the design and deploys the system. But again, is the system design correct? Is it meeting the requirements of the SL? At least now we can validate and verify that it does within the standard. The handover and the maintenance procedures that occur within there, is that designed with the agility to move forward, especially with these long legacy propositions that you could have within the OT area. It's making sure that that is built into the concept that you're developing. And then finally, as I said before, ensuring that the providers, the vendors that are there with the hardware and the software are meeting the compliance with regards to the standard, so it can be implemented into an overall solution. Ultimately, we are trying to achieve, and this is where the end user needs to understand their positioning. They're interested in PL. They're interested in the protection level. They want to ensure that what they end up with as a system meets those requirements. So if we look at the way these are brought together, the way that they're constructed, the PL requirement is a combination of the SL, the security level, which is the technical measures, along with the ML, which is the maturity levels relating to processes and procedures. And only when they combine do we ultimately get the PL. So the matrix here is ensuring that all of them are combined to achieve the right outcome. That means we can now follow and work with all parties to ensure that we're bringing that together for the right level of protection, the right level of management, and the right level of resilience that we want to build into these systems. These combinations of the SL and the ML and ultimately the PL ensures the processes, the technology, and the people are all working together. But again, make sure that the processes are correct for what the scope is, make sure the people involved are the right people to be involved, and make sure the technology is the right technology. Once we've done this, you can now start to define your architecture. You can look at developing how this interaction will take place. We can start to build definitions of how this is brought together. We can look at bringing the products into play that ultimately lead to a defense in depth approach. Around this, we can define the products, the connectivity of the products, how they work in conjunction with the rest of the system, how they are interacting, what information is being driven from that system. And ultimately, what we want to do is to have a blueprint of the way the system has been designed. Why? Because eventually this will give us a security design specification. This will define the front end of exactly what we're putting together around with all the other elements relating to the engineering that we're trying to define. Add that to ensuring that what you're doing within the process, that end-to-end approach of making sure that we have at the front end the audits, making sure the implementation stages are maintained, making sure that security optimization, the management of the system, is also maintained as well. And what you should be seeing, and what our customers, we want them to see, is an end-to-end solution for their systems, looking at the integration of IT and the threats from the IT, but also looking at the way that we handle that physical layer as regards connectivity in the solution. There are many competency measurements that are there. Siemens, for example, have recently achieved Cyber Essentials and Cyber Essentials Plus. Nothing at all to do with OT. But what it does put a statement is that we ourselves, the way we handle our own data and the way that we handle our internal security. And I would argue that when you're looking at companies that are engaging with you, look at how they are handling their own security in their company, because that will define how they handle the security with you as regards your solutions and what's being implemented. Another good area to, as I said before, about trying to get information, where you get information from. There are various areas. At Siemens, we offer a product cert. It's free of charge. You simply put your email address in. And using RAS feeds, it provides information on a global basis, not just around Siemens product, but generally within the ICS community of exactly what's happening out there and what you should be made aware of. So overall, it's about education, educating your people, educating yourselves. The engineers out there need to be aware and more aware of their responsibilities from a security perspective, and ultimately ensuring the technology that you're using is engineered correctly. And those engineering disciplines are still important and should still be important in this digital age. Fundamentally, they should be at the core of the decision-making process for the solutions that you have. That concludes the presentation. I hope you've enjoyed it, and I hope it's answered some of the questions, and I think it's open to questions now.
Yes, thank you very much, Paul, for a very, very topical presentation. Only this week we saw the chaos caused in the US with the malicious hacking of the oil pipeline. So a very topical presentation. One question to start with, you know, it's a very complex subject. Where do we start on this journey of cybersecurity? You know, what are the sort of a small number of key areas to address?
I think that what we should be doing is ensuring we know the estate. We know what is is actually connected into the architecture themselves, into their control systems. What we find is in excess of 95% of customers that we work with is that they don't actually know what's connected into their estate. So the first thing is know what's connected, know what you're working with, get the baseline so that you can have real constructive discussions with the providers that you're working with.
Right. What do you think the landscape will look like in the future for cybersecurity in terms of legal technology issues?
Well, we're seeing legislation now from a legal perspective. We're seeing that going forward, there will be legal requirements around security, and that will be attached to the legal requirements around safety. So I think you will see an emergence of these two engineering disciplines becoming closer. 62443 has already been amalgamated and draws reference now from 61508, and there will be emerging solutions that will cover both security and safety. I think that security will become part of the overall project technical files, and I think you will see more relevance to the way these systems are designed and also meeting the requirements of the standard in the future.
Well, thank you, Paul. We've just about run out of time. I'd like to say a big thank you for that presentation. Over 50 people were listening to that, so it's obviously very popular and pertinent. And I would just suggest that anybody with any more questions should contact you on your stand. So again, thank you.
Apologies for the beginning. Teams
Yes.
It got to me good and proper. So
okay, well, it all turned out all right in the end. So thanks again, and thanks to everybody else for coming along. Thank you.
Thank you, and good afternoon. Cheers.
Bye.